So learning target 1.5 on the Unit 2 test. Now I'm going to look at the revised one that people took the second time around, but they were actually very similar to each other. The first one says sketch and label a concave pentagon. So a pentagon has to have 5 sides. Concave means that there's one side that kind of, two sides that kind of cave in. So first I need to just do a 5-sided figure, and you can use your template for part of that if you want to. Now it does say to use a straight edge. It's kind of difficult to do that on this thing, but we will see how this goes. So I need to have 3 sides, and then I need to have 2 more sides that cave in, and I'm going to kind of freehand draw that just because of the limitations of the Mimeo and how long it takes to do it otherwise. Now, it says name the diagonals. It doesn't say draw the diagonals. Name them, and be careful with your notation. Well, I have to name the diagonals, then I need to name these vertices so I can name the diagonals. So, I'm going to just call this A, B, C, D, and E. Now, when I name the diagonals are segments. When it said be careful with your notation, it means make sure you use segment notation. So let's start with point A. A diagonal would go from A to C, so segment AC. Another diagonal will go from A to D, so segment AD. And that's it, because A to E, that's a side, A to B is another side. So now going to B. B to D would be a diagonal, so segment BD. And from B to E would be a diagonal. So BE is my segment. Now C, I've already done the diagonal from C to A, but there's also a diagonal from C to E. D, I've already done the diagonals to B and A. E, I've already done the diagonals to E to C and B. So those are my 5 diagonals for this concave pentagon. Now it says a convex polygon Parker. Here's the problem. Teachers like to get cutesy sometimes, and we like to have our polygons have names. So instead of just doing A, B, C, D, E. I will tell you that when I edited this, I didn't go and actually do the answer key for this before I gave it to you. I was kind of surprised that no one in the class told me that this was an impossibility. You cannot sketch a convex polygon Parker. Now, the problem is R is used twice. You can't have 2 different vertices labeled R. So if I had said P-A-R-K-E, and I'm going to change this to a T so that these are all different, now I can sketch it. It doesn't say this needs to be regular, so not all sides have to be congruent, but honestly, it's just easier to put your template down and draw in, and this is the template on here, so it's a little bit sketchier, and label it P-A-R, and I'm going to change it to Parkit just so that I don't have that double R problem. And I did this because one of my dogs previously was Parker, so I was using her name. So you don't have to use the template. You could have just used a straight edge, but it does have to have 6 sides, and if it says it's got to be this name, you've got to put the labels on the vertices as well. Equiangular triangle BUN. Now, it said equiangular, and I'm going to have to freehand draw this one because the one on the template isn't all that good. So, let's see how this goes. So, equiangular, B-U-N. So I need to label it B-U-N. Don't forget your labels. It's an equiangular, which means the angles are equal. It says nothing about the sides. Do not do more notation than they are asking you to do. Equiangular means the 3 angles are congruent. I put that notation in. I make sure I have my B-U-N, and I stop. Now, equilateral, quadrilateral. Quadrilateral means it has to have 4 sides. Equilateral means that the sides are congruent to each other. It says nothing about the angles. So, What you're really drawing here is a rhombus. And if you have some way to do that, and I don't see anything too well that's just a four-sided figure that's not going to be a triangle or something, there is on your template a rhombus that you can draw. Too small for me to use it on here, so I am going to have to kind of freehand draw this instead of using a straight edge just because it takes so long on here to do that. Assuming I used a straight edge here, it's M, N, P, and Q. The sides, because lateral means sides, the sides are congruent. Nothing said about the angles. The angles do not have to be congruent. Do not do the notation for congruent angles. Regular hexagon. Well, I did that just a minute ago. That is big enough on the template to sort of do on this. And it doesn't say anything else about it. It doesn't give me the name of the hexagon. What I do know is it's regular, though. So the only way that people know that this is regular is if I do the notation. All of the sides are congruent, and all of the angles are congruent. If you don't do both of these, then this is not regular as far as the rest of the world is concerned. A diagonal is a segment that connects, oops, wow. I do not know why this thing's going all insane. We'll have to see if I can get this to work. If not, then I will have to figure something else out. So, as a diagonal is a segment that connects two non-consecutive vertices of a polygon. Now, the common mistake, people said two non-consecutive points of a polygon. I agree that vertices are points, but let's say I'm looking at this rhombus sort of looking thing, at least this quadrilateral. If I want to talk about the diagonals, if I just say two non-consecutive points, well, there's a point and there's a point. But you know what? The segment that connects them is absolutely not a diagonal. But if I take a vertex and another vertex that is not right next to it, so not the next one in line, that is a diagonal. So connects two non-consecutive vertices of a polygon. Congruent polygons are polygons that have the same size and shape. Now, some people in the first time they took this test that said all the sides are the same length and all the angles are the same measure or something. And I said, does that mean they have to be regular? No, they don't. If I look just very roughly, let's say this triangle, and let's see if I could possibly duplicate it. Assume these are exactly drawn the same. These two triangles are congruent. They have corresponding angles that are congruent to each other and corresponding sides that have the same length. But they could be scalene triangles, and as long as I could take one and move it on top of the other one and it would be a perfect match, they are congruent. Thank you.